Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast brought to you by Nutrien Ag Solutions. The first picture looking at here is one of the more iconic pictures we have of the way that a temperature inversion, which is where the temperatures increase with height rather than cool with height, how a temperature inversion can trap smoke. So the base of the inversion is here, and the warming is happening above that, and we're not getting the vertical mixing of this smoke into that layer. Now, the reason why I start off with that is because I want to take you back to some satellite imagery from the other day. Now, just before we lost GOES 17, so GOES 17, I believe, is mostly offline, we could see yesterday the smoke from the fires that are in Northern California. Now, do you see these little, almost like little tendrils right in through here? Same thing from the fire that's in this part of Oregon, and even you can see it in the cloud cover here along the coast and on the I-5 corridor. What's happening is there's an early morning temperature inversion that is wearing away as the day goes on, as you see here, and the fog and the smoke lifts out of those valleys. So the effect of the inversion is to trap the smoke into a lower layer of the atmosphere. Now, thinking about that smoke here, as you watch this animation, has been spreading throughout the country. And I want to just make a point here about the flow of the smoke. Just notice that in general, it's doing something like that. The trajectory is something like that. That's the flow of the upper levels of the atmosphere, and we're going to have to discuss that here in a few moments. But actually, it's important that I talk about the flow of the upper levels of the atmosphere, because this morning I was in Sioux Falls. I had to fly back to Chicago, and then from Chicago this evening I flew into Charlotte, North Carolina, which means I was in this smoke in an airplane for much of the day today. And I'm going to talk to you about that because I took a couple pictures out of my window. Now, off in the distance, there is a storm, at least a storm that's trying to get going here in the southeast. But what I want you to notice is that there's a layer of cloud here, there's a layer of cloud here, there's another one way down below, and in between there's a lot of murky haze. Up here, I'm looking into the stratosphere, and down here, I'm looking into the troposphere. And we're basically flying right at the boundary of where those two meet. Now, take a look at this. This was a weather balloon giving us what we call a sounding, taken this morning from right here in North Carolina. Okay. Now, what's interesting about this is early this morning, there was an inversion near the surface. There was a temperature inversion about 3 kilometers above the surface, another one at 6 kilometers, and then this one up here where the temperatures are warming with height, and that is the base of the stratosphere. Now, what's neat about this is that I saw these 3 layers in my picture as I flew. So again, there's basically the top of the atmosphere, top of the troposphere, getting the stratosphere. That's also where the top of that storm is located. Then here's that middle inversion, and then the lower one is down here. Now, why I illustrate this is because the smoke from the western wildfires has been able to penetrate clear through these layers deep into the upper levels of the troposphere, and it is spread across. And in fact, as I was flying in just about an hour and a half ago, you can see here the extent of the smoke carried clear from the west all the way over to North Carolina, where I'll be spending the day tomorrow at an event. So just amazing to see how this all kind of plays out in the atmosphere. And by the way, as we were landing into Charlotte, I know you can't tell it, but Charlotte's in the background here. It's actually the smokiest I've ever seen it on a flight. And now I know I've never been out west for those fires, but it's amazing to see this, all the way on the other side of the country. So I thought you might like to see that as well. Now, my discussion from here goes into a discussion about the temperature pattern, because over the last 30 days, so this gets us back to the third week of June, we can see that our temperature pattern has favored the greatest heat in the west, in the northwest, expanding through the Canadian Prairie and the northern plains. And there's been a very distinct cool signature downstream of that here from the central and southern plains through parts of the Corn Belt over to the southeast. We can put some numbers on it as well. So from June 23rd to July 21st, this map shows you the rank and the 129 years worth of data where the temperature during that time period sits. And so the West is breaking all-time records for this 30-day time period. But what I want to do next is I want to show you this. You see, the upper levels of the atmosphere and the temperature, the flow of the jet stream, the height pattern we always talk about, all of that is a reflection or is the result of the surface temperature pattern. And then the two work in concert. So what you've got here is looking back from the 20th of June to the 20th of July, what the upper level flow of the atmosphere has looked like. And it's primarily been a large ridge planted here. So the flows come around and had to go over that ridge. It's then cascaded down like this before trying to rebound over a ridge just off the northeast, which is why at times the northeast has been warm as well. But this has been the placement of the ridge during that time period. Okay. Now, first question, how well did the forecast models predict that? Because that's going to help us with the forecast going forward. So I went back and looked. The weather forecast we had released on June 21st, which is what we're looking at here, said that from then until July 21st, that this would be the most likely location of that ridge. Now the issue is the height lines in through here were a bit too flat, which means the model didn't quite pick up on the true amplitude of the ridge, although it got the downstream effect pretty well. Now, just speaking about the success of this model, that's a 30-day forecast that the model produced, and it verified relatively well, picking up on the pattern. And I would call that a pretty big success or a pretty big win. But if I come back to this, I want to do a little comparison year to year. This map shows you, again, 2021, and just so you can see the difference between when there's drought west and when there's drought in the Midwest, this is what things look like in 2012. Same time period, June 20th through July 20th in 2012. So look at the differences here. Trough over Alaska, ridge north of Hawaii, the jet stream has to fly between the two. It then dove down here over the west and then ran up over the ridge, which was parked somewhere between the Dakotas and Minnesota. So the flow went over the top like that. So the difference in the temperatures and the precipitation is in 2021, the ridge has been here so far. In 2012, it was much farther to the east, and that is ultimately what we're trying to predict and see where things are going. So just to show you, remember we looked at this map a moment ago. That's our temperature pattern over the last 30 days. This is what it looked like in 2012. So again, June 23rd to July 22nd, 2012, the cooler weather was along the west. And what you have in the central part of the United States was the extreme heat. We can also do this. This is the latest drought monitor update. We've seen, as I talked about on Monday, extensive record-setting drought in the west, and it's expanded to northern plains. And it's a very unique view of what the drought looks like. But that same weather pattern I showed you right here, which happened in 2012, gave us drought that looked like this. So that was the drought monitor by the time I got to July 24th in 2012. So just a good way to compare two different years and see what those differences are. Now, where is this pattern going? So why am I talking about that? Well, the jet stream level flow, the 500 millibar flow right now, has a couple of troughs in place here. And the flow is pretty far to the north. And there's a ridge that's been over the west, and it's going to be expanding toward the Midwest and even toward the central plains of the United States as well. So the pattern we're about to get into is going to be changing considerably, and I want to show you that first. So we're going to look here at the European model 12Z run. So again, this came out after the markets closed today. And what I want you to see is the jet stream level winds and how they're going to evolve. Ready? As we play this forward, going through Friday and into Saturday, Sunday, and Monday. The jet stream is very far displaced to the north. It's here through the Canadian prairie, and the ridge has opened and expanded in this area. We have a trough hanging out here just off the coast, and another one extending from the Hudson Bay. And that's going to be a critical piece right here, this trough from the Hudson Bay. Because as we go forward out to next Tuesday, Wednesday, and Thursday, look at the extent of this large ridge that is planted over the midsection of the country and how it's opened toward, the parts of the Mid-South. The jet stream is very far to the north a week from today, and as we continue to play this forward, we're going to see it's going to be like that as we finish the month of July and then get into the month of August. So thinking about that, it's got me saying, all right, where have we been lately with precipitation? So this is our last 30 days of precipitation anomalies, and this has been the area that has very much struggled to return moisture. That's been a constant discussion point for us. And there are pockets throughout the central plains that have been dry as well. But we know that we've had a very wet quarter in through here. It has extended at times into the northeast, and lingering, slow-moving boundaries plus cutoff lows over this part of Texas just keep bringing in the moisture to the south and east while the west stays exceptionally dry. So the question we're going to propose and then try to answer is, what changes are going to be happening to this map? So the soil moisture equivalent here, so we're looking at now percent in soil moisture, shows you that same precipitation pattern and where things have been dry. So I wanted to provide this update for you. Now going forward in this forecast, Over the last 72 hours, we have seen the southwestern monsoon deliver locally heavy rain here, produce a lot of lightning in the west, which is starting to ignite some of those fires. But it's all running around the flow like this and then the broader flow like that. So what this has done is we brought in some rainfall to some very dry areas. This is not corrective on the drought, but it is rain from some scattered storms. The lingering frontal boundary here across the south with the constant pull of moisture into that is what's made it wet there. But the midsection of the country right in through here has been dry while the storms have kind of pulled off here into the northeast. So that's just your last 3 days. Where is it going? Well, in this video, rather than stepping through every 6 hours in the models, we need to get the bigger picture here. Because as that ridge expands, we're going to watch this corridor in through here, kind of paint it like that, for having some of those ridge riding storms. Now the models every day will flip-flop on who's getting the heavy rain and not, because they're not designed well to predict convective precipitation thunderstorms. So we look for the corridors. But if I can kind of remove that drawing and just say, as the flow comes over, we'll watch through the Ohio Valley even for the potential for some of these storms. It'll be scattered daily convection across the south, and you can still see the strength of the southwestern monsoon where we do have flash flood watches out for that area. Now that's the 12Z European, this is the 12Z GFS, and we see the same features. Southwestern monsoon, scattered storms here, and then the flow coming off of that ridge, opening up into Ontario through the Great Lakes states, a lot of storms coming out of the northwest flow over that ridge, which we've been talking about for a while. So maybe it'd be instructive if we just kind of show the accumulation of precipitation from the European, remembering that these models, the European and the GFS, which are our only two models that run out this far, they will move the precipitation on every run, okay? So we're looking for the pattern. So the first thing we see is that through Friday and Saturday, that's when I'm rocking back and forth through here. This is the corridor we're going to watch come over the ridge and deliver thunderstorms in through this area. So we'll watch it, we'll nowcast it. That particular system, as it pulls into the northeast, will leave a weak frontal boundary here after the weekend. And what's going to happen is the models are picking up on, see it there Monday, Tuesday, the better chances for storms in this area, also down here in parts of the southeast. There's our southwestern monsoon. Now going from next Tuesday into Wednesday, Thursday, and Friday, can you see how the models continue to kind of open up this corridor for bringing in some storms? I know I can show you kind of the snapshot here of what it looks like, but I want to remind you that each new model run will give a new solution as to where these storms will go, and we will not know until the storms initiate exactly who will get the rainfall. But in the center of the country, kind of in through this area, it is going to be isolated at best with storms, and a lot of them will be hit or miss, and many places are going to miss out on it. Now from there, we do have some tropical development we're going to watch. There's going to be possibly a tropical disturbance that gets pulled off toward the north and east like you see here. It's not a threat to the U.S., but I just want to point out that the National Hurricane Center does have it up to a 30% chance of developing into a depression, but it's going to move away from the coast and not be a major threat. What I think is more important is the fact that we're going to move the MJO out of phase 5, which is just north of Australia, and it appears to be kind of going through the western Pacific phases and resetting itself over by Africa. Now, we've had this theme kind of going in our discussions lately, because what that ultimately means is that if you look at these diagrams here, at the end of July, going through the beginning of August, you start to see where this green shade shows up here. So this is time in this direction. That is over Africa. And the net effect of that is to increase our velocity potentials in that region. Decrease them. So to make a point here, what I'm trying to tell you is we need to start watching in August for systems to be coming off of Africa. And as I have pointed out, the wind shear across the tropics in the Atlantic is very low compared to average, which means should a system get into the main development region of the Atlantic or into the Caribbean, into the Gulf, the wind shear values are low enough that it won't shred it apart, disrupt the vortex, or spread the heating. So that's important to know as we look forward in this forecast. Now, let's come back to the bigger picture. Latest European ensembles looking at the probability of getting an inch of rain through the next 10 days. And what you see are the same patterns that we discussed. The highest probabilities are in this area, right along the Gulf Coast, and here in the southwestern monsoon. There will be isolated thunderstorm events in the Midwest, in the western Corn Belt, the Red River Valley of the North, that those isolated storms do put down some heavy rain, but it'll be an isolated event. Now, from there, take a look at what the GFS, the 12Z GFS ensemble does. Remember I said that how important this trough was right in this area? Well, we see the jet stream level flow coming around like this and breaking up into what seems to be a ridge here, but to the south of it there is a trough. Can you kind of see the height lines dipping? We call that a high over low. And if the jet stream blocks up into a high over low in the Gulf of Alaska in this area, what it could do is back the ridge farther to the west. It is still quite open, as you see in the ensemble average here. But what happens is with the downstream trough, this area in through here will likely continue to see above normal precipitation. And that's what we get here. Let's zoom out so we can see the whole graphic. This is the 12Z GFS ensemble week 2 forecast. And you notice that we're wetter in the high plains up in the mountains here. That's part of the southwestern monsoon. And we see this corridor here wet, and it extends off into the northeast. Why is it so dry in the south? Well, the models aren't seeing the daily convection, and there's no big tropical system coming in there. And that ridge opens up right into this area, so the southern plains could go over hotter and drier. I'll show you the temperatures in a moment. But the European ensemble sees a similar pattern through the 5th of August. You notice it's almost a copy here of what I just showed you from the GFS in the overall precipitation pattern. So that's some critical information there. Now from here, why don't we talk about those temperatures? Thursday's high temperatures very hot where I left this morning, and 10 degrees cooler where I've arrived this evening. But we know that the ridge is going to do. So by Friday, heat coming into the western Corn Belt, storms down here. This is why it's going to be cooler in the desert southwest. And then going into the weekend, it's going to be hot through much of the central part of the United States, above average in the west as well. As we go into Sunday, now the ridge is opened. There's Monday's high temperatures, and Tuesday, that's when the ridge is firmly planted right over the central part of the United States and the central and northern plains. Extremely hot for this time of year. And it's going to last for several days next week. In fact, just looking out there at day 5 through 10, you can now see where the heat is going to be centered as we finish the month of July and start August. Extremely hot in this area, okay, compared to normal. From there, let's try to get at the longer term answer to our bigger question. What's the pattern doing? Well, if you were to ask me what the average jet stream flow looks like in August, I'll just point it to you by looking at the height field. Generally, the jet stream comes in like this and has a split piece here, and therefore there's a ridge right there. That is the climatological average flow of the jet stream in August. That's taking the 1948 data to 2020 and averaging it. Now, why I show you that is because we get this precipitation forecast from the European weeklies, which were just released about an hour and a half ago. And if you look at it, it is really showing a lot of moisture. And it's raining across a broad sector of where we grow crop in the United States. The Canadian prairie is dry. And I say, well, how reliable is this? So if I go up there and I look at that upper level flow pattern, what I would make the case of saying here is that there's a lot about this pattern that seems to be just showing us climatology. Do you see it? The ridge is there. So the model is seeing this flow coming out of this direction, and it's not blocking the Gulf of Mexico flow or the Atlantic flow. So it's bringing the moisture into this area, and it's got to do something with it. So the model has to be consistent and pulls the moisture out, and that's what you end up getting. So again, this was just released just a little while ago. On the temperature side of things, well, here's that same pattern. It's warmer. The jet stream is farther to the north, and that's a result of it being warmer across the whole of the United States. It appears that the greatest heat will be concentrated in the Intermountain West toward the northwestern Canadian prairie. So let's keep going with this question as we finish this up. Is there support from some of the other models? Well, this is the CFSV2 forecast for week 3. That's the 5th through the 11th of August. And this is the week 4. And we notice that it's trying to do something similar. Keep the Gulf open. If there's a place that's going to be dry, it's going to be a bit farther to the north through the Canadian prairie. You see that in both models. So at this point, I'm just to be honest, I'm explaining to you what the models are saying, but I'm also trying to explain that the models are not offering any sort of strong predictor away from what we would call climatological average. The momentum is low, the MJO is resetting, and I think those factors are, when you take all the different model ensemble members, put them all together, you're getting normal, you're getting average. But I can say this. Let's do one last set of maps. June 20th to July 20th, we have seen high pressure setting up here, here, and here. Now, the net effect of that is that the flow comes around each one of these highs in a clockwise manner. Oops, let's maybe redraw that last one a little. Well, we'll keep it going. And the last one has been curling the moisture around, whereas this one's been pulling the dry air out of Canada. And it's all been meeting right here. The flow that's come into this has pulled that smoke from the west up around that ridge and delivered it to the rest of the U.S. But because of that flow pattern that we have been seeing, this is what we got in terms of precipitation anomalies. Where it all met, it was very wet. Where it didn't, it was dry. We know that there will be a deviation in the jet stream level flow over the next 10 days. But I do not see any model shutting down that big Bermuda high, pumping in all that moisture. And that's the thing I'm going to keep a very, very close eye on, because not only does it pump in the moisture, it also steers any would-be tropical system that'll develop. And you know we're going to be watching August carefully for that. So I appreciate your attention this evening. I hope you all have a good rest of your day and a good weekend. And we'll talk to you again soon. Thank you.